roll in. Okay, so last time, in a record that was unfortunately lost, we had our first explorations of Cassandra in a concerted way. And I wanted to rehearse a little bit of what we did there before going on to some additional material that would be of strong interest, I think, for those pursuing the projects. Namely, with Cassandra, getting access not only to the survey data on the one hand, but also to the data, from the sensors, but also survey data. So you may recall the Spark configuration procedure that we went through last time. One is starting Spark up. Now, if for the initial installation of the Cassandra connector, you may need to start Spark with a reference to that package, so it loads this Cassandra connector up front, okay? And I've gotten kind of mixed indications about whether you have to start it from the Spark folder. Last time, ladies and gentlemen, my problem was I configured it. You may remember that we ended the class on a big bang, not a good one, because basically we went through a set of steps, led to a crescendo, and the crescendo fizzled. It crashed and it died in a horrible way. So the problem is I had loaded the wrong version of the Cassandra connector. So we need to load the right version. And in fact, I had corrected the Spark configuration file on the Moodle site for that. So we're gonna get that started, and then we're gonna go on and we're going to go through some rituals to sort of get the initial connection set up within Spark. So here we're gonna go and let's go call up our Spark Spark folder. So here I am in my Spark folder. You'll have a similar thing, and you folks will recognize there's this conf, and that has various information. You'll notice there's also this jars file, jars, that has lots and lots of jars that are used here, including some that we'll be drawing on today. They include this thing, for example, OpenCSV, to make it easier to open CSV files. I think the Zookeeper is associated with a social media package. I think maybe Twitter, and there's a variety of other items here. So jar files can be placed in here for easy loading within Spark, and you can. In fact, I think I had indicated in an email. If I didn't, I will shortly do so, where you can, in your Spark configuration here, your Spark defaults.conf, you can specify Spark packages that you want to load, but also Spark jars that, so this is a bigger package here, but you can also specify Spark jars from that jars file, and it will load them in automatically, okay, when you start up. But let's go start Spark. Yeah.
You had lots of jars there, but you are not loading all into your shit, yeah?
It's a good question. I think some of them are automatically loaded when you load certain packages or built-in packages.
So those you showed us were built-in jars, or you had added them?
No, I didn't add all of these. So a lot of these are built-in. I added some of them. I added some of them.
So when you are it's not in a separate folder. It's added to the jars folder.
Well, I think this is one of the places you could put jars that it will look for jars. So if you say Spark, and I think the thing of the config file is you put in a Spark. In addition to spark.jars.packages, you can put in spark.jars, and then that will get loaded in. The jars you specify will get loaded. Others of them are pulled in automatically because Spark needs them, or because this thing needs them, the packages need them, or what have you. And I think by default they get loaded in from the jars folder. That's one of the main places it goes to load these things.
Sometimes I'm not sure that when we define it in the config file, is
Yeah.
it going to download them into the folder, into the bin folder, or no? We should put them already there in the folder and then describe it.
It's a good question. I think spark.jars.packages may be loaded automatically by Ivy. It goes and resolves it. So this Breeze Viz, for example, I think it goes in this one. It goes to the Maven repository, and with Ivy, it sucks down all the jars. But sometimes you just want jars put in that you downloaded yourself.
Right.
And I would put them in jars, and I think what you do is you specify spark.jars without the packages at the end. You give a list of those jars, and it will suck them in when you start it up.
Okay.
That's my recollection of how it works. Okay. Now you'll notice this is set to use this Cassandra connector 2.11. Last time I had it as 2.10. This was the line I commented out, and it's actually 2.11. So I'm going to start the Spark shell, okay, with the confidence that it's going to load that in. So starting up the Spark shell, it's going to be loading in these packages, and it's going to be getting certain types of information, I think, from this this online site, including this Breeze in Breeze Viz 2.11. Okay, so here we're starting it up, and now having gone through and starting it up, and it's still finishing here, we are going to subsequently then go through a certain ritual to sort of get it going here. Okay. So it's still going through its startup procedure here and telling us certain information is available. You'll notice the Spark context is available. That's our default Spark context. And in this case, because we're going to be using a Cassandra context, we actually want to not use that. So the first thing we're going to do here is we're going to sc.stop. So that's our Spark context here. We're going to stop it. Stopped. Okay. Next, we're going to import jars that we need for the Cassandra connector. Okay. So I'm going to do import com.datastacks. I think Datastacks is the creator of this Spark connector, or one of the main players in it. And I'll actually do these out individually, so you could see if one fails, which one it was that failed more easily. Spark context. Okay. And then import org.apache.spark context.underbar, and then import org.apache.spark.sparkconf. Okay, so again, we're importing Spark connector, things associated with it, Spark context. The underbar is all the things associated with it, and this would include implicits, things that sort of convert automatically behind the scenes from one thing to another, know how to convert one thing to another, and then org.apache.spark.sparkconf. Okay, make sure that all of those are loaded in. Okay, now, having done that, we are going to configure the Spark configuration. Okay. Now, last time I actually revealed my password, so I had to immediately get it changed, and I'm not going to be doing that again. So each of you will enter your own password here, and meanwhile, when it comes time for me to enter my password, I will blank the screen. Okay, and pause the recording. Yeah.
File and then load it.
That's a good idea. That would be a safer bet, wouldn't it? Do you have information about how we could do that?
Mohammed once told me that you can do that, but not how. I will figure it out.
Yeah, that's great. Or we could ask someone else too.
Yeah.
Okay, so ladies and gentlemen, we're creating a new. Oh, that's. Yeah, it should be Spark conf. So we're creating a new Spark conf. And then in the Fluent style, this is called Fluent style, we're setting successive properties on it. And you notice these things come in pairs. We're setting the connection host to Blinshiki. We're setting the auth.username to be your new username. Set spark.cassandra.auth.username to be your username. Okay, Nate in my case. And then, in the moment hopefully not everyone is waiting for, cassandra.auth.password, we're going to set it to your password. Word, just like that, okay? Now, let me ask about this Fluent style. Is this inherently imperative style? In other words, are we updating properties on this thing, or could this be done in a functional way? Think about what's going on here, these successive sets. Does that mean it's actually mutating properties? It's actually, adjusting properties in the underlying object?
No.
No. It could just be returning an object with successive annotations.
It has to, because
Indeed.
otherwise you can't call set on set.
Precisely. It needs to actually return a value, and that's my point. So set, it's easy to mistake from looking at this that somehow set is mutating things. But in fact, set is being used here in a functional way to just say annotate it with this extra bit of information. Pass it on.
And
return the value.
So it can do it again.
Exactly.
So this is literally exactly the same as map and filter.
Exactly.
And
Why
what
don't
if you change those sets?
Well,
The place of set first is Spark Cassandra.
then it will just do the annotations in successive orders. The ordering shouldn't matter.
No.
Yeah, it shouldn't matter. Okay, now's the moment where I do my secret things. Okay. Indeed.
Just pointing out.
Yeah. So I've done untoward things on video before. AnyLogic claims that they have a video of me from one of my boot camps, where some of my boot camp videos posted to YouTube, where when they went and looked at it more closely, as I'm flipping between screens, one of the screenshots, if you freeze it, is the list of all the people in the room and whether or not they've paid for the boot camp.
Yeah, AnyLogic is really, they care about this thing.
Yeah.
That's okay. I think that what Dr. Stanley said about the RNA-20 class one day was much funnier. He's like, I mistyped one letter in a URL, and then found out, some websites are educational, but some of them are educational.
Right. Okay, new Spark context. Okay. And this is going to be, we're going to be doing this on a local host in an application that's it's going to be called the test application, right? Or we could call that something else. We could call it, Spark, or Cassandra survey access. How's that? There. And then this conf. Whence did this conf come?
That was the thing you're not going to show us.
That's the thing I'm not going to show you, but I asked you to enter, right? This thing, val conf equals spark conf true in this successive series of sets. Okay, here we go. Boom. There we go. Okay, ladies and gentlemen, we're off to the races now. Okay, now there's a few more things I want to do here before we get going. One is to import org.apache.spark.sql.sql context. And basically we want to do val SQL context dot equals new SQL context of the new Spark context. This is the new one we just created, so we wanted to to do that. And then I want to import SQL context dot implicit dot this. Now, these parts are not part of my slides, and they really should be. So I hope you won't mind if, for your future reference, I go and I add these here as part of the further configuration. Okay, so you just know the rituals you got to go through to make it a happy camper. There we go. Okay, so
Step 1 in here.
additional. What's that?
I didn't see,
Step 2. This.
I didn't see step 1. Sacrifice a goat.
This is right. This is step. So Cassandra connector step 1. Okay. So here's step 1 and step 2. Great. So that will be there for your future reference. Okay. So now we're in good shape. So what I would like to do now is to just test out something here. And then we're going to get going. So we're just going to rehearse a tiny bit what we did last time. So we're going to open up a full table on Cassandra. So to do this, we do SQL context. What does this DF stand for? Anyone? Data frame. We're going to read, and the format will be org.apache.spark.sql.cassandra. Okay. Great. Options, and we have to give it a map. And a map in Scala, you can indicate what's the key and what's the value with a little sort of arrow sign. And so this is going to be, this is the key space, and the arrow is Ethica study 73. Okay, and then there should be a quote there. Yeah, and then so that's one item in the map that we're creating. The other item is table is GPS. Okay, we're going to revisit this when we do the survey thing here in just a minute. So so that's our options, and then we're going to do load here. Okay, now so in other words, we ask this SQL context, okay, go connect to a Cassandra data source with this information about what we want to connect to. A certain key space, that's how Cassandra maintains parts of its databases. And then we're going to open up a certain table, okay? We're going to do GPS as this. And it's going to go off and think, as it is right now, and it's going to come back with a data frame, okay? Is this data frame a typed data frame? Is it strongly typed? Is this? Well, the schema is known, but it's actually not able to infer at the level of kind of the typing and the command. Now you may ask, okay, what do we have to do to add typing? Anyone remember? How do we turn this to a fully typed thing? We'll put a schema in. We'll see that in a little bit, okay? And in general, my own view on Spark, and I'll mention this again later, is that that by and large you can work in a type-safe way, but there's going to be little bits of vulnerability where you're using a data frame temporarily. But by and large, things are type-safe, okay? The arrays you get out of it are type-safe, the data sets. It's just there will be times where the data frames are used. Okay, so ladies and gentlemen, I've given you a little exercise, in fact, for Thursday where you'll explore this more. But just to help you, remind you of some of these things, we could do a print schema, and we could see this is the schema. So it has latitude, longitude as a provider. This is network or satellite, essentially, although I think satellite's called GPS. It has a timestamp, curiously, as a string, an altitude, a sort of which way you're facing, user ID associated with it, a date, etc. Okay, this is the device it was captured on, and a GPS speed. Okay.
Why the timestamp is a string?
Mumble.
Well, I mean, the date as a string makes more sense.
Yeah, a date. I'm not. You'll notice there's a record time, which is in fact the timestamp. So I'm not quite sure the difference between this guy and this guy, if one is rounded off in a certain way, or one's local time, the other's UDC time, sort of a universal time, independent of time zone. I'm not sure. I'd have to go look into that. Okay, so this is the GPS schema here, ladies and gentlemen, and I will do something here that that's going to that's going to go and get something. I'd ask that maybe you hold off for now. We're going to do dfgps.filter, and I'm going to do the accuracy. I'm going to filter out values, so just retain values. So the accuracy is less than 20 meters, grouping by the provider, and then I am going to do ag of count of the number of that sort, okay? And I'm going to do show, okay, now, so, okay,
Val
so
DFGPS.
okay, so,
Give me a name for the
oh, so Val, I don't know, sorry, I started typing something that doesn't meaningful. DFGPS filter. So what is this going to be doing? Can anyone tell me, roughly? What is this command?
It's going to give you the count of how many of the records, a count by provider of things that are accurate between 20 meters.
Yeah, for the subset of the data, which has a resolution of more finely than 20 meters, it's going to count the number of those that were based on network, in other words, Wi-Fi locationing versus satellite positioning. Okay, and you'll notice that here, this group by, this is breaking into these different providers, and then the aggregation is counting up the number that fall into each bin, right? Notice that it's a little bit confusing to say accuracy is less than, because we're actually asking for things that are more accurate, that have finer resolution than 20 meters.
That's basically your absolute.
So this is basically, it's actually it's your standard deviation associated with your signal, estimated standard deviation according to signal. It's a little bit confusing, but this is what I get at. So this is some sensor data, right? And we could load in similarly accelerometer data. We could load in data from Bluetooth or load in data from gyroscope, etc. So we've seen last time and here, a little bit of indication of how we might be able to work with some sensor data. Today, my goal is to get you something else that will be really important. We'll come back and deal some more with sensor data, particularly cross-linking sensor data with survey data, for example, cross-linking different tables of sensor data. We'll be doing that next week. But right now, I wanted to get you a sort of indication of how you can access survey data, because I think many of you may seek to use that for your projects, and you may be interested in how we could link it in. So what I'm going to do is I'm going to retrace some of the steps, ladies and gentlemen, that we pursued here, okay? And specifically, we're going to go back to when we opened this up, and instead of doing DFGPS, we're going to do DF survey responses, okay? Survey responses. Now, can anyone guess what is it in this that would probably have to change if we didn't want GPS data, but we instead wanted survey data? Yeah, the table's going to change. And you'll be heartened to hear that it changes in a predictable way. So instead of being GPS, we'll say survey responses. Okay?
Well, I mean, you could also use a different study, right?
Oh, yeah, we could have used a different study. That's right. It's just everyone in the room is guaranteed access to this study for this class. Mohammed, create a
Is there a way
copy.
to show all the tables here, like
To show what the space is.
key spaces
Yeah.
and all the tables? Through the CQ list.
Through the CQSH, I'm not.
Previous information about the tables.
Yeah, it's a good question. I think there probably is. I just don't know what it is off the top of my head. But I think there probably is that you could query things. Okay, so ladies and gentlemen, we basically just changed this and that. That's it. Okay. So now we have this DF survey responses. Okay, so let's go check out. Let's suppose we want to see what sort of information we have on these. What do we have to do? Yeah, let's go look at the schema. DF survey responses.
There.
Sorry?
Before the V.
Survey. Print schema. Okay. Now, this is a different kettle of fish. What is different about this, other than the names of the things and what types they are? Yeah, what's different here? There will be a JSON file, but what particularly is different here that we didn't see when we looked at DF GPS? It's nested. Notice this. With DF GPS, we just had it all sort of at one level. Now we actually have some nesting. Okay? But otherwise, it has a lot of similarity. I mean, with DF GPS, we had user ID, date, device, record time, and timestamp, and then a bunch of GPS-specific things. But these things here, these metadata here, were pretty common. Let's go look. So again, this was DF GPS, user ID, date, device ID, record time, and timestamp. User ID, okay, survey ID, subsurvey, record time, device ID, timestamp. Pretty similar in terms of much of the metadata. But here we have survey ID. We're going to have a duration, which is, I think, the time until it was answered or canceled. Okay. So let's do a little bit of additional frobbing here, and then we'll start to get into more of the specifics. Okay.
One thing we could do is with this is take survey responses. We know the timestamp, assuming that's the start and the duration, and then create a substructure in like a join table of all the GPS locations they were at while they answered this survey.
Correct. And we'll be doing that another time, but that's correct. Yeah, GPS locations, or we could look at what was their accelerometer, in the 5 minutes before they answered the survey and so on. Okay, so ladies and gentlemen, let's go here and let's do a group by. Okay, well, first of all, let's cache this. What does it mean if we're going to go cache this? What's the significance of that?
You don't want to recreate it.
Yeah. You don't want to recalculate it every time. You'd like to cache it, keep it around. Right. Prefer not be tossed out of memory, for example. So if possible, store it in memory. Okay.
There's an option to keep it in memory and disk. But
yes.
Here, I think you haven't.
I think by default it's
the SC.
The SC. Well, you can actually specify it. There's a persist option here where you can actually request exactly for a particular one of these how you want to try to keep it, right? Okay, so let's group by survey ID. Oh, Windchill's gone too. Okay. Group by the survey. Group by survey ID. By that column. That's what the $sign means. And actually, let's also group by sub-survey ID. Sub-survey ID. Are we okay with this? And then let's go and do. So we're going to do an aggregate. Again, how am I going to count the number that fall into each? Sort of, for every combination of these, I'm going to count the number. How do I do that? Ag, count, star, yeah. Okay. What does that look like? Where does this come from? That's SQL.
Yeah, it's like star from blah 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 blah.
Yeah, exactly. It's kind of weird. I consider it a little bit weird, the syntax, but okay, fair enough. So here's a count. You notice that the survey IDs, it's only showing the top 20 rows. Most of them only have one sub-survey. Maybe we'll just group it by survey ID. Okay. Okay. There we go. Boom. Okay. Okay, it's showing the top 20. I think I can do like top 100. Boom. Okay.
Couldn't we sort this by the descending number of responses? Like by the count that we get?
Yeah, we could.
What are the 20?
Yeah.
20
Yeah,
surveys
so,
that we got?
okay, good. So how do we do that? What do we have to do? I heard
I
it.
think it was sourced by appetizer.
Actually, you can do order by.
Ah.
Order by. And what would be the thing that we'd have to order by? By what would we have to order by?
The aggregation.
Yeah, so the column name, this thing here. So how do we rename that? Well,
As?
there is an as, and it might work, but we used before with column renamed, was it? Something like that. And this has to be in quotes. Okay. Boom. Okay. Here we go. Oh, okay, mumble. So there's got to be some way.
So you ordered them, and then you showed.
Sorry.
You could do the same thing for the.
Can I do reverse? No. Okay. Okay. How do I do descending? That's the thing I don't know. Maybe you can do descending or something like that. Okay. Okay. If someone could figure it out, that's great. But surely there's a way to have it descend here.
200 and then order by count, or is it?
I don't think so. Okay. Order by in Spark.
I'm looking it up right now.
It's too bad we can't put like negative of it. Right. Actually, so here we go. Okay.
You apparently it's sort, then you put descend, desk, and then the column name you want to sort. Except
okay.
Ordering by,
this works. No. Do this. Yeah. Look at that. Look what I did. I just did minus of it.
Nice.
Of that column. Okay. Okay.
That's
So
amusing.
so here's survey 147 has 1,163. Survey 244 has 1071.
The way it's in this.
Yeah.
In the sort method, you put the column name and after it desc.
Oh, okay.
To get it done.
So alternatively, I could have done it like .dsc, not yeah.
I mean,
Like okay.
inside
okay.
the column.
Okay.
Right after the column.
Yeah. So you could have done basically this would have been an alternative. Thanks. That's great. So like that.
I think the minus sign came from importing the implicits for the SQL context. I don't know.
That may have been, but the minus just takes it minus of the whole column, and so it's
right,
sorting by that. Okay, so that's another way. With you basically treat it as a column, and then you say descending.
Mm-hmm.
Okay, so it's kind of a descending column.
Nice.
Okay. So, ladies and gentlemen, here we're getting some information. You could see some of these surveys actually have quite a few responses for them. Good. So maybe what we'll do is we'll take one of these. I think I'm going to take one that we'll be working with here. And I chose survey ID, I think, for example, 242, which is an exercise survey. Here it is. It is 555 responses, okay? And what we're going to do, so for survey 242, we are going to go count the number of responses. Okay, so so 242, survey ID 242. We're going to group by the sub-survey ID for the to see how many things are of each sub-survey. Okay, I'm just checking. Yes, so it is sub-survey. Okay, great. So, ladies and gentlemen, suppose I wanted to check for survey ID 242, how many times that had been filled out. What would I do? What would I type?
Well, first you just filter out anything that doesn't equal 242.
Good. Okay. So let's try this. So survey ID. Now, what do you think I put here? Okay. Well, let's suppose I put that. Do you think it'll be a happy camper?
No, it's a string, isn't it?
It's unhappy.
Oh, it's a column name. Okay.
Okay. So what do you think I should put? Remember, we're testing equality.
Double equals.
Okay. So that would be a good thought, because after all, single equals is assignment typically in Scala, right? Okay. So we'll do double equals. What do you think is going to happen? Is it happy? Happy or not?
No.
Not happy. Okay. Oops. Sorry.
Triple equals?
Oops. Sorry. Turns out, ladies and gentlemen, that you have to do a triple equals. Okay. Triple equals. Now, how if I want to count the number for this? What would I do? Count. Okay. Okay. 555. Great. Now, suppose I wanted to break these down by user ID. What would I do? How if I want to get the count for different user IDs that filled these out?
Group by?
Okay. Group by and what? User ID. Okay. So we'll group by the user ID here, ladies and gentlemen. And what would we typically do here? We would
count, or we can add count.
Okay, what would happen if I tried to do show here? It's going to be unhappy because it's got a relational group data set. What do I have to do to turn this into normal columns? Well, I have to tell it how to aggregate things that are grouped into the same category. So let's go through the little thing we've been doing. This thing, we could average things up, but in this case we're looking for a count. So I'm not going to do that, and I'm going to do show here, okay? For different user IDs, who's contributed? Okay. There we go. Okay.
So you had two users who answered the same survey.
Different numbers of times.
That's
Yeah.
a lot of times.
Yeah. And one of them may be a computer scientist because he answered it exactly 56 times. And I'll have to tell you, that user happens to be in the
The
room.
user ID is very famous. You can see it in every study that's presented.
Yes, he's in many studies. He's highly involved in our research. Okay, and I would venture that he may be a valuable contributor to most of the research. So, okay, so ladies and gentlemen, so here we have a grouping by user ID, right? But let's go back and reflect on this. We could do a similar thing for grouping by, print schema, right? For grouping by other things too. We could have done it by device ID, or we could do it by the sub-survey ID or what have you. Let's suppose we wanted to do duration. Let's rehearse that again. How do we do duration here? Suppose we wanted to group it by to see how quickly they answered it, or how long it took. What would we do here? We've done it before. What can we group by? What would be the most naive way to do it?
You could just group by the duration.
Okay, let's group by the duration. What do you think we'd see if we saw that?
A lot of single records.
Okay, duration. Okay. Okay, not the most pretty of things,
I love
right?
your error code.
So what should we do in order to sort of sort it? What do we have to sort by? Sorry? Run?
Yeah.
Round.
Oh, round. Yeah, we're going to do that. That's exactly what we're going to be doing. First, let's order it by. Let's sort by duration. How do we sort by duration?
Just order by.
Order by duration, right? Duration. Okay, and here it's fine to do it from smallest to most, right? And it's only showing the first. Now, I think each of these means something different. I think one is expired and one is canceled or something like that. And then you could see the most common one here is answered with
You
within.
need to plug your computer in.
It's mumble.
Just noting.
It's exhibiting dysfunction because it's not, the power is not making it to the computer. Okay, ladies and gentlemen, we're set for a crash unless we do something soon. Okay, this is an adverse circumstance. Okay, pardon me. Let me save what little we have.